Hello, so today we are going to do problems from weekly contest 332. The second problem is count number of fair pairs. So what this problem says is we get an array of numbers of size n, and we have two integers, lower and upper, and we want to return the number or the count of fair pairs. And by fair pairs here, they mean that the sum of the elements is in the range lower to upper, right? And the indices needs to be different, of course, right? One of them smaller than the other. So for example, here in this array, the pairs that have validated that condition are 0 and 4, because the sum then is 4. 4 is between 3 and 6. And so these are 0, 1, 2, 3. This is this one. These are the indices, by the way. And then 0 and 4 also, that's a valid one. 0 and 5. 5 is between 3 and 6. 1 and 3, right? That's basically 1 plus 4, which is 5, which is in the range. 1 plus 4, again, still 5 in the range. And then 1 plus 5, which is also 6. 6 is in the range because this range is closed, right? Like here and here, okay? So the total number of these pairs is 6. So pretty straightforward to visualize. Now, in terms of constraint, the length of the array is 10 to the power of 5. The range itself is 10 to the power of 9, right? So this already tells you can't try every pair of indices in the array, because that would be at least 10 to the power of 10, right? And so we need to find a better solution here. So let's see how we can solve it. So the first thing we need to think about is, let's sort the array, because what we are trying to do is find a sum of two elements, right, for I and j, that are smaller than an upper value and smaller than lower value. So to be able to make any assessment on like moving pointers or anything, we need to sort, okay? But if we think about sorting, there is one thing we need to think about, because the problem says we need I smaller than j, right? For if we take nums of I plus nums of j, right? But if we sort, we need to think about, does this impact this at all? Well, it doesn't, because if we take the sum of num at I plus num of j is actually equal to the sum of a num at j plus nums of I. So whether I is smaller than j or I is bigger than j, it doesn't matter. We can just flip the order, right? And so this tells us that it doesn't matter which index is smaller than the other one. All that matters is that they shouldn't be the same index, right? You can't add the same the number from the same index. And that's logical, because we want two different numbers as a pair, right? And so sorting, this means that sorting won't actually impact anything, because as long as we don't take the same index twice. Okay, so we established that we can sort. Now, how do we approach getting the two numbers, counting the pairs where the sum is between upper and lower? So we need to think about something here. So I have an array here, right? Just a drawing of an array where these are, let's suppose that these elements here are those that have this condition valid, I and j, sum between upper and lower. Okay, if we assume that, then we know that this portion here, right, it's all the pairs that have the sum smaller than or equal to upper, right? Because these here, the pairs here, are those that have the sum between upper and lower, right? And so these are all those that are smaller than or equal to upper, because they go up to the start. And these from this side here, these are those that have the sum smaller than lower, right? Because those that we have here are exactly bigger than lower, bigger or equal to lower, right? And those here are smaller than or equal to upper, right? So that means basically that to find this here, we just need to find what are the number of pairs that are overall smaller than or equal to upper, and we need to find those that are strictly smaller than lower, and that will allow us to find the remaining portion, which is those that are strictly between lower and upper, right? That are exactly between lower and upper, right? Just simple array subtraction here, right? We have a bigger set, we subtract the smaller set, we get the remaining set, right? And why do we do this even? Because calculating this here is a lot easier than calculating this. Calculating this and this is a lot easier. It's just counting the pairs that have a sum that is smaller or equal than a single value. And this here is just counting the pairs that are smaller than a single value, right? And so if we sort of say that P of smaller than or equal to upper, so this would be just the number of pairs that is smaller or equal to upper, and this is the number of pairs that is smaller than lower, then this is exactly our answer that we are looking for. This is the pairs that are between lower, that have the sum between lower and upper, right? And so if we sort of, since this one takes just the smaller or equal to lower constraint, let's try to make this match the same format. And so we can just make this be smaller than upper plus 1, right? This is the exact same thing. So this here is the exact same thing as doing this, because smaller than if you have something smaller or equal to upper, it's the same as it's smaller than the next value, right? Because here we have only whole integer values, right? And so the problem now reduces to just finding this here, right? So how do we do it? Well, we just want the count of pairs of numbers that have the sum smaller than upper plus 1, and we want the count of pairs that have the sum smaller than lower. So we need just one function that calculates the number of pairs with sum smaller than some value x, right? That's what we want, and that will, if we have this function, we can calculate both this one and this one. And so for that, we can actually use 2 pointers to count this, to count the number of pairs with the sum smaller than x. And we can apply this only because we sorted the array. So how does that work? So let's say we have this array here. We can just have our pointer here and here, right? And as long as the sum is bigger than the x value, we need to reduce the sum to have a chance for it to be smaller than x, right? And so we just reduce j we move it to the left, right? If the sum is still bigger than x, we move it to the left. So we keep moving it to the left until the sum is smaller than x. And the first time we find that the sum is smaller than x, that means basically that, so let's say for example here at 5, now we find that the sum is smaller than x. Well, that means that this entire portion is pairs that have sum smaller than x, because taking the biggest value, right? By the way, just to clarify what I mean here, it just means that pairing 0 with this one would be smaller than x, with this one would be smaller than x, with this one would be smaller than x, and with this one would be smaller than x, right? Okay, and then we move I and try again with the rest, okay? I hope that was clear. So let me just clarify again. So if we fix I and j here, and we want to just find the j's that pair with this 0 so that the sum is smaller than x. So we start out here, we find that 0 plus 7 is not smaller than x, then we move j here, and if we find that this is smaller than x, that means all the range here can be paired with this value to give us a pair that has the sum smaller than x, right? And so what this would translate to roughly is, let me just clear this up so that this is a little bit more. So what this would mean basically here is that we will say, okay, 0 plus 7 is, so our x, by the way, let's say upper is 6, so our x would be 7 because we pass, remember, upper plus 1, okay? And so this is 7, this is equal to 7, so it's not smaller, it's not less than x, and so we move j to the right, because to have a chance to get a smaller sum, we move it to the left, right? So move j, now j is here, 0 plus 5, that's actually smaller than 7, so we are good. And so what do we take? Well, that means we can pair all of these with this position I, right? And so that means what we need to add to our result count, we need to add all of them. What are all of them? This position 0, 1, 2, 3, 4, right? It's just j minus I, right? Because that would give you actually 4 minus 0, and that's exactly what we want, 4 elements. And that's exactly what happens because the pairs are 0 with 1, 0 with 2, 0 with 3, 0 with 5, right? And then we move our I pointer in the next iteration. So basically we have a while loop, right? Where first we move the j's until we get the proper window, we add the elements, and then we move I. And so now we move our I value to this position from here. And j stays here, by the way, right? It doesn't go to 7, right? And so now we check, is 1 plus 5, which is equal to 6, smaller than 7? Yes, it is, right? So now we add j minus I, which is basically just j is 4 minus 1, so 3. And does that work? So we added 3. So while we pair 1 with this one, so that's the first one. We pair it with this one, that's the second one. We pair it with this one, that's the third one. And so we have 3 exactly. So that's what works. And then we keep doing this. We move I again here, and then calculate how many we have until I and j meet, right? And that's pretty much it, right? And then with that, after that, we return the total count, and that will give us all the pairs that have a sum smaller than x, and we apply it to these both, subtract, and we get the result, right? Even though this was lengthy a little bit, all you need to retain is that we are counting the number of pairs smaller than an x value, and because we have this subtracted by this, we get the result, which is those that have the sum between lower and upper range, right? Okay, so that's pretty much it for this solution. Now let's implement it and make sure it passes test cases. Okay, so now let's implement the solution we just saw in the overview. So what we need is first to define a function that has for pairs that count the number of pairs with sum less than x value, right? That's the function that we are going to use. And what we said is first we need to sort the array, and then we could use this function here to count those smaller than upper plus 1. So that will give us all those smaller equal to upper, and similar one here, smaller than lower, and this will give us those with the sum exactly between upper and lower. So this is what we need to return. And now we just need to define this function. So we need 2 pointers, one at each of them at the far left and far right. And while the 2 pointers have not met, we want to do while they have not met and the sum is bigger or equal to x. That means it's bigger than x, right, or equal to x. So to make it smaller, to get to smaller than x, we want to move j to the right to have a chance of having the sum smaller, right? So we do j and 1. And now we need, of course, the overall count. So let's call that count equal to 0, and that's what we want to return at the end. And so here, what do we need to add? Well, we said it's just j minus I, right? Those are those between pairs with I and let's call this k, such that k is basically in the range I plus 1 to j, right? So those are the pairs that we count here. And then we want to increment I plus 1. Okay, and that should be it. So if we run this, looks good. And it passes test cases, right? Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one.